Welcome to the AWS Architecture video in the Cisco Secure Firewall in AWS video series. Hybrid Mesh Firewall is a new market category that focuses on unifying physical, virtual cloud, and agent-based enforcement to simplify security operations. This video is intended for anyone who wants to better understand Hybrid Mesh Firewall solutions. Also, network security practitioners who are looking to extend their skills into the cloud, and cloud practitioners who want to understand how security solutions are implemented in multi-cloud and hybrid cloud environments, and frankly, anyone who wants to better understand AWS and firewall deployment in the public cloud. The objective is to provide an understanding of AWS architecture sufficient to deploy and manage security solutions. The prerequisites are a basic understanding of network technology and network security, at least for physical networks. The fundamental video of this series, or comparable AWS knowledge, is expected. The architectures discussed in this video are VPC peering, transit gateway architecture, AWS Cloud WAN. We'll also discuss how to connect an on-prem network or other public clouds together with your AWS environment. We conclude with a discussion of load balancing and horizontal scaling. Let's first look at VPC peering. VPC peering is the simplest way to connect VPCs. It supports a simple hub-to-spoke model. However, there is no transitive spoke-to-spoke routing. It has limited routing options. The next hop in a route table is always the peering connection. It cannot specify a destination within the target VPC. Therefore, it's not suitable for firewall insertion. Furthermore, it has poor scalability. Since routing is not transitive, you require, for full mesh, an order of n squared peering connections for n VPCs. Let's move on to transit gateway architecture. The problem that transit gateway architecture solves is managing the connections between multiple VPCs in a scalable manner. It overcomes the VPC peering limitations and reduces operational overhead. Transit gateways act as hubs, and VPCs act as spokes in a transit gateway topology. Transit gateways provide granular routing control. It supports both static and dynamic routes and uses specialized route tables to choose egress attachments for traffic. The different attachments can use different transit gateway route tables. There are various types of transit gateway attachment. VPC attachments connect transit gateway to the VPCs. VPN attachments connect on-prem data center, branch office, or other cloud environments to the transit gateway through a site-to-site VPN. Direct Connect gateway attachment is utilized with AWS dedicated private network connection called Direct Connect. Transit gateway peering attachments allow you to connect two transit gateways together. And a Connect attachment can integrate certain third-party virtual appliances, most commonly SD-WAN appliances, with the transit gateway. Transit gateway architecture can provide centralized security for an AWS environment. This is accomplished by having a service VPC, which is attached to the transit gateway and contains the security devices such as Cisco Secure Firewall. Load balancers within the service VPC can provide scalability and redundancy. The details of the routing for centralized security with transit gateway architecture are included in the routing video of this video series. Let's now discuss AWS Cloud WAN. AWS Cloud WAN addresses global network complexity, which may include multiple transit gateways, diverse connections, lack of central visibility, and substantial manual configuration. Cloud WAN abstracts the underlying complexity by using a policy-based automation model. The key components of AWS Cloud WAN are the global network, the core network, which is the backbone of the global network, the core network policy, where you declare your network's intended state. This policy describes the AWS regions in your network, how your network is segmented, how attachments are mapped to segments, and how routing between segments is achieved. Segments are similar to virtual routing and forwarding in a traditional network. Attachments are connections from VPCs or on-prem networks into the core network. Here for your reference is a table contrasting AWS Transit Gateway Architecture and AWS Cloud WAN. Firewall placement for AWS Cloud WAN is beyond the scope of this video series. However, there is a blog, the link to which is given in this slide, that provides a detailed discussion of this implementation. This implementation unifies infrastructure for security and global networking. It simplifies multi-regional security deployment, seamlessly integrating Cisco Secure Firewall and utilizing Cisco Firewall orchestration with Cisco Multi-Cloud Defense, creates ease of management, provides consistent security policy across a global cloud network. Let's discuss connecting an on-prem or other public cloud network to your AWS environment. Direct Connect is a dedicated private network provided by AWS to connect data centers or colocation environments to AWS Cloud. The physical connection is a dedicated fiber optic cable from your network router to the AWS Direct Connect router at an AWS Direct Connect location. It utilizes virtual interfaces to provide access to AWS service. There are private and public virtual interfaces, as well as transit virtual interfaces to connect the transit gateway to provide centralized access to multiple AWS VPCs. Dedicated connections can be provided to individual customers that have high bandwidth requirements. Customers with more modest bandwidth requirements can use hosted connections provided by an AWS Direct Connect partner. AWS also has a technology called AWS Site-to-Site VPN, which relies on an AWS object known as a Virtual Private Gateway, or VPG, attached to a VPC. It acts as a logical router on the AWS side of a VPN connection or AWS Direct Connect connection. It acts as the entry point for encrypted traffic from your on-prem network into your AWS environment. It enables private and secure communication between your data center and your AWS VPC. It can propagate routes to and from the VPC using BGP. You don't need to use an AWS construct to get connectivity between public clouds or from an on-prem network to the public cloud. You can use third-party products such as Cisco Secure Firewall. These third-party products can replace the VPGs. This simplifies administration by insulating the administrator from the details of AWS VGP deployment configuration and troubleshooting. It can also unify VPN functionality and other security operations into a single entity. This may reduce cost by avoiding the purchasing of the VPG. You can connect a VPN directly to the transit gateway to avoid having to connect to multiple VPCs. The routing configuration is straightforward. The on-prem configuration is simply to determine which traffic should be sent through this connection. Transit gateway and VPC routing configuration are discussed in the routing video in this video series. Transit gateways provide dynamic routing by utilizing BGP exchange routes between customer environment, represented in AWS by an object called the customer gateway, and the transit gateway. The key benefits are centralized connectivity, simplified network architecture, enhanced scalability, increased resilience, and cost optimization. For all of these solutions, it's possible to do your firewalling on-prem before you send the traffic to the cloud, or as the traffic is received from the cloud. However, you may wish to do the firewall placement in the cloud. When you do this, the firewall treats the on-prem to cloud traffic as it would other east-west traffic. Third-party solutions, however, can offer an alternative because you can combine the inspection and the VPN functionality into a single device in the cloud. Let's go on to load balancing and horizontal scaling. It might be worth remembering that AWS stands for Amazon Web Services. Historically, scaling was simply having a service, like a web server, and having that scale horizontally. Network load balancers provide scaling for services offered in the cloud. External load balancers have front-end service definitions and perform destination NAT for inbound traffic so that the servers see their own IP addresses in the packets received from the internet. Internal load balancers can be used for east-west and outbound traffic. Network load balancers can be integrated with firewalls in most deployment scenarios. However, network load balancers are not ideal for firewall insertion. That is why public cloud providers introduced gateway load balancers, first introduced by AWS in November of 2020. Unlike traditional load balancers, these are specifically designed to work with intermediate devices such as firewalls. Gateway load balancers allow transparent insertion of firewalls into the data path by encapsulating the data in a Geneve tunnel, which is very similar to VXLAN, and sending the packets to and from the firewall. Because of the encapsulation, the packet headers never need to be modified. Gateway load balancer architecture consists of the gateway load balancer itself. This is similar to a network load balancer in that it has a front end, a back end, and health probes to identify healthy or unhealthy back end members. It also consists of a gateway load balancer endpoint. This endpoint is dropped into the packet path and it intercepts the packets and sends it to the gateway load balancer through a private link. The gateway load balancer and gateway load balancer endpoint can be in different VPCs or even different accounts, and there does not need to be connectivity such as VPC peering or transit gateways between the gateway load balancer endpoint and the gateway load balancer. There's also an endpoint service. This is how the gateway load balancer endpoint communicates with the gateway load balancer. It subscribes to a service published by the gateway load balancer. Here's the traffic flow for this architecture. Traffic is intercepted by the gateway load balancer endpoint and sent through the private link to the gateway load balancer. The gateway load balancer encapsulates the traffic in a Geneve tunnel and sends it, along with metadata, to the firewalls. The firewalls process the packets and send them back through the Geneve tunnel, and then it is returned through the private link to the gateway load balancer endpoint. Details of the routing required for this architecture will be provided in the routing video in this video series. There are also DNS load balancers. These work by updating DNS. They modify either the A records or the CNAME records of DNS queries. The data path does not actually go through a separate entity. This is ideal for load balancing remote access VPN. Examples for AWS are Route 53, but other public cloud providers also have DNS load balancers, such as Azure Traffic Manager. Application load balancers act at layer 7 and can do very granular application load balancing. Here we see an example where images are sent to an image server pool and video is sent to a video server pool by parsing the HTTP URL. Generally, when we're dealing with firewall placement, we put the application gateway behind the firewall, and the application gateway front end acts like any other server with respect to the firewall. This video series contains 3 videos that give detailed information about deploying Cisco Secure Firewall clusters in the AWS environment. Here we give a high-level discussion. Clustering of Cisco Secure Firewalls combines multiple Cisco Secure Firewalls into a single logical device. This allows you to pay as you grow, increasing the number of firewalls up to 16 nodes as your security throughput demands increase. Cisco clustering may provide resilience dependent on the external load balancing solution. For physical devices, where this technology was first developed, Ether channel is utilized, and LACP provides resilience, state being replicated within the cluster. For virtual devices, resiliency depends upon the load balancing capabilities of the cloud environment. For AWS, only gateway load balancers provide this resilience. This is quite old cluster technology. It goes back to the ASA before even the acquisition of Firepower by Cisco. It was later extended to physical firewalls using Cisco Secure Firewall Threat Defense, and more recently to virtual devices. Porting clustering to the public cloud required significant modification. For physical clustering, data interfaces could be either individual mode, different IPs for different nodes, or spanned interface using Ether channel with a single IP across all nodes. Because we don't have a good analog of Ether channel in the public cloud, we restrict to the individual interface mode when deploying clusters in the public cloud. The cluster control link utilized a proprietary protocol over IP in our physical clusters. In the virtual clusters, we replaced this with VXLAN over UDP to be better handled by the public cloud environment. Cisco clustering technology symmetrizes asymmetric routing. To do this, it may have to send packets across the cluster control link between the nodes. Therefore, the cluster control link has to have an MTU that exceeds the MTU of the data links by enough to have the appropriate headers attached to the packet sent across the cluster link. Now, because of the difference between the cluster link protocol in physical clusters and the cluster link protocol in virtual clusters, the MTU has to be increased in the virtual clusters by 160 bytes. Also, the lack of broadcasting within the public cloud required us to replace broadcasting with unicasting, and that means that we need a static peer list to construct a cluster in the public cloud. AWS introduced a feature called Target Failover in October of 2022 for its gateway load balancers. If the Rebalance Existing Flows attribute is enabled, existing flows are reload balanced to the healthy nodes when a node is identified as unhealthy. This feature, combined with Cisco Secure Firewall clustering, provides connection level resilience. Note that Google Cloud provides the same functionality through an attribute called Never Persist that you can set on your backend pool of your load balancers. Thank you very much for your time.